7 dot product. So let me write down definition first. Dot product. So let U, V be two vectors in or n. We know that that is n dimension, right? Then dot product U. So we make a dot a little bit bigger. Normally we make it like that, right? So emphasizing this is a dot product. So it's V equal to summation of K equal to 1, 2, and U sub K and V sub K, right? So if we extend this one, when K equal to 1, we have U sub 1, V sub 1, right? When K equal to 2, we have U sub 2, K2. When K equal to 3, U sub 3, K sub 3, until U sub N, K sub N, right? Oh, no. I made a mistake. V sub 2, right? Oops. V sub 2. All right. Sorry. I'm so excited. That's why. V3, V to the, not to the V sub N, right? Okay, let us do this one. What does it mean? Find U dot with a V. So dot product of U and V, we can read it that way, for vector U, which is 1, 2, 0, -1, and V equal to 0, 1, 2, 3. Okay, now how do you find U dot with a V? Okay, so we make a first component with the first component. So that will be 1 times 0 plus, we added them because we are following this formula, right? And 2 times 1 plus 0 times 2 plus -1 times 3, right? Can you please calculate this one? Thank you, -1. All right. Can you please try this one then? Find V dot with W. So dot product of V and W for V equal to 4, 3, 1, 5, and W equal to 9, 2, -1, 6. Okay, V dot with W. Can you please try? So what did you get? It's a 71? Is it correct?
Yeah, I got 71.
Okay, thank you. So proposition, properties of the dot product. So let K, P, R scalars, U, V, W, R vectors. Then the dot product U dot V satisfies the following properties. Okay, first one, dot product of U and V is the same as dot product with V and U. This is we say the commutative law, right? So dot product with U and V is greater or equal to 0. And if this is equals to 0, then we know this notation if and only if, right? If and only if the U equal to 0 vector. And third one, we have KU plus PV dot product with W. Then we can do this way. So that will be K, oops, K, U vector with a vector, so dot product with a W. Plus P vector with a vector with a dot product, right? Next, we have U dot with a KV plus a PW. Then we can do this way and this way, right? But then we make a dot product with a vector, all right? So that will be K and U dot product with a V plus a P, which is a scalar, dot product with dot product with U and W, right? Okay, next we have the two absolute value. So looks like absolute value, right? For two lines squared. Okay, this means U times U. U times U mean I meant dot product. Okay, U dot product with U, right? So we call this is magnitude, right? So magnitude, which is length. Okay, then we have this notation. Then there will be, yeah, I think so, yes. So magnitude of U, which is square root of U sub 1 squared plus U sub 2 squared plus U sub 3 squared and plus U sub n squared. So we add everything up, okay? All right, so let me prove the last one. Proof of V, which is magnitude of U squared, which is dot product of U and U, okay? So we know that magnitude of U, if we indicate the three component, there will be U sub 1 plus U sub 2 plus U sub 3 and square them, right? By the definition here. Okay, then we have, if we make a square them, then let me just copy this one squared, right? This is squared, right? Okay, if we say that this is squared, then we have a square root, then this will be only inside square root, right? So that will be u sub 1 squared plus u sub 2 squared plus u sub 3 squared, right? Okay, we have square means that u1 dot u1, right? Plus u2 dot with u2, right? So there will be u sub 1, u sub 1 plus u sub 2, u sub 2 plus u sub 3, u sub 3. Okay? All right. Then we can write as a vector notation. So that will be u sub 1, u sub 2, u sub 3 dot product with u sub 1, u sub 2, u sub 3, right? Because we had earlier, if we have a dot product, we multiply component with component, right? To get the number, right? So this is simply vector u dot product with vector u, okay? It's okay with you? Okay, thank you for responding. All right, let's do it. Find the magnitude of u equal to 2, 1, 4, 2. Okay, so magnitude, we denote like this, or length of vector, right? So then we know that since this is, let's say that this is u sub 1, u sub 2, u sub 3, u sub 4, we can make that square root of u sub 1 squared plus u sub 2 squared plus u sub 3 squared plus u sub 4 squared, right? Okay, so that will be your turn. Can you please calculate? Five. Thank you very much. Okay, now we have a theorem. I will not prove this one because if you take the advanced linear algebra upon division, they prove for you. So Koch, Schwartz, inequality. So this time they're using absolute value. U dot with a V. Okay, this is absolute value. Absolute value means they don't want the negative, right? Okay, less than or equal to magnitude of U and magnitude of V. So someone said in the chat earlier, right? So we call this a magnitude. It's a fancy word, and or length. And sometimes we call the norm, okay? So 3 different names, but it's the same, okay? All right, so we have a theorem, triangle inequality. Let me prove this one. So we have a theorem, triangle inequality. So for vector u, vector v, EC, or n, we have experience and dimension, right? So we have triangle inequality, magnitude of u plus magnitude of v less than or equal to magnitude of u plus magnitude of v. Okay, So with the proof. So we want to start square first. Magnitude of u plus magnitude of v squared. This one we had experience earlier. We can use dot product of twice of them, right? So that is the same as u vector u plus v dot product of same thing, right? Okay, so not magnitude of u square, which is u dot with u, right? Okay, now this one we can use this way. U plus u, no, not plus, dot. We make a dot, and then dot, plus, and then vector v, dot with vector v. Okay, I made a mistake here, right? Crazy. Okay, this one should be parentheses. Rushing this one. All right, then this one. Do you agree with this one? So we will have this one. Look, u square plus 2 uv plus v squared, right? Do you agree with this? Yes? Okay, thank you. Okay, then this is less than or equal to, we will make we are using same, but we are going to use the absolute value of a second term plus 2 u dot with v plus v. Okay. So we have an equal sign, so we are good, right? All right. So then there will be, we can express as u plus, hold on 1 second, plus v and square them. Yeah. So basically, we do reverse. We make them, right? So u square 2 times this times that. Well, we are using absolute value instead of a magnitude symbol plus a v square, right? We're going back, right? Yeah. Okay, then we just conclude. We start with that, right? We start. So that will be magnitude of u, magnitude of v squared equal less than or equal to the last sentence, which is parentheses with magnitude of u plus magnitude of v and squared, right? Okay, now we want to prove this one, right? So we have a square, so we take the square root to both sides. So take the square root. So just make a copy. And copy. Okay, then we get only inside, right? So there will be u magnitude of u plus v less than or equal to magnitude of U plus magnitude of V, which is we designed here, right? So this is how we prove. Okay. Any question? Okay, then let's see. We call this is a vector V. We call this is vector U. This is we call the angle. We have another proposition. Dot product and the angle. Okay, so we often use dot product with the angle related, and then later on projection. So let U and V be two vectors in Rn, and let theta be the included angle. Then vector U dot product with V. So we are using angle related with the dot product. Then we have magnitude of U and vector V and cosine theta. Okay, now if we solve for cosine theta, then we can express it this way, right? So U dot V over magnitude of vector U, magnitude of vector V, right? Is okay? Okay, now let us find angle between vectors. Given by vector U equal to 2, 1, negative 1. Vector V equal to 3, 4, 1. Okay, so we have the formula here. So let's apply this one. Copy? Okay, so U dot with a V, that is first component with the first component. We multiply and add them. 1 times 4 plus negative 1 times 1, right? Over magnitude of U means we have 2 squared plus 1 squared plus negative 1 squared. And the magnitude of V means 3 squared plus 4 squared plus 1 squared. Okay, Yoja, can you please calculate? Okay, pick anything. You pick numerator, please calculate the numerator. You pick this one, please pick this one. Calculate this one. And you pick this one, please calculate that. All right? Give it to me answer. It's a 14, thank you. So looks like a numerator, 14. And Okay, we take so long time. So how about this? Can you please confirm that? Okay, so let me explain to you in your chat. So this is the formula. We are using it, right? So this is the formula. This formula. Okay, yeah. The magnitude of U, yeah, we are using this formula. Okay, so we are using that. All right, so maybe you guys confirm this work. Can you confirm this is the right one? Yeah. Okay, then theta will be inverse of cosine 9/2 square root of 39. Can you please approximate as a radians? Okay, takes a long time. So 0.7662 radians, please confirm. Okay. Okay. It's good. So we measured in angle. So we have acute angle. So acute angle means less than 90 degrees. So we might think just quadrant one, right? So acute looks like that. So vector V, vector U. So cosine theta is between 0 and 1 because cosine 0, what do you get? It's 1, right? Very good, thank you. And cosine 90 degree, which is cosine, yeah, thank you. Pi over 2, which is 0. Excellent. Thank you so much. Okay, now we have obtuse angle. This means the angle is between 90 degree and 180 degree. So we might think of quadrant 2, right? Okay, so the angle looks like that. Vector V and vector U. So angle theta here. Okay, so this means cosine is between -1 and 0 because cosine 90 degree, what do you get? We did earlier, yeah, thank you. And cosine 180 degree, which is pi, which is cosine pi. -1. Excellent. Thank you very much. Okay. Number 3, we have opposite direction. Thank you in the chat for participating. And opposite direction means straight line, right? Okay, so if we have vector u, so opposite, so say vector v, or we can say the negative of vector u. We learned that last time, right? Okay, so in that case, the theta will be 180 degree, right? Straight line, right? Hi. So we had a cosine 180 degree. We had earlier cosine pi, which is negative. Okay, same direction. If we have a vector u goes to this direction, and the vector v goes the same direction. Okay, in that case, cosine theta equal to 1, because theta, which is 0, cosine 0, which is 1, right? All right, now perpendicular, number 5. So perpendicular we learn from the algebra course, right? But then more advanced course we call orthogonal. Yeah, orthogonal. When you hear this word, it's the same as perpendicular. Okay, that means we have a vector u and perpendicular vector v. That means 90 degree, right? So cosine theta equal to 0. Then the theta must be 90 degree, which is pi over 2. So cosine 90 degree, which is cosine pi over 2, which is 0, right? Okay. Let's do this example. So let UV vectors with magnitude of u equal to 3, magnitude of v equal to 4. Suppose the angle between u and v is pi over 3. Okay, find dot product of u and v. Okay, so we are using the related with the angle. That is magnitude of u, magnitude of v, right? And cosine theta. Okay, now magnitude of u is given, which is 3, right? So 3 there. And magnitude of v, which is 4. And cosine pi over 3, right? Because they say that angle is pi over 3. So cosine pi over 3. So what is the cosine pi over 3? Yeah, it's a 1/2. Good. Now, can you please calculate? I'll do more faster. 6. I can see it directly, right? Okay. Confirm. Very good. Thank you so much for confirming. Okay. All right. Let's do another proposition. So perpendicular vectors let U and V be non-zero vectors in Rn, then U and V are perpendicular when dot product equal to 0. Say the think the dot product is 0 perpendicular. Yeah. So if you take the calculus 3, you will use that a lot. Perpendicular dot product is equal to 0. Okay. All right. Determine whether the two vectors so U equal to 2, 1, -1, V equal to 1, 3, 5. Yeah. So determine whether the two vectors something missing, right? Are perpendicular. Very good. Orthogonal. Very good. Okay. Okay. So in order to find orthogonal perpendicular, we have to check that, right? Check it out. So you start with the V. So first component with the first component. So 2 times 1 plus 1 times negative, positive, positive 3, -1 times 5. Can you please calculate? Yeah, she already confirmed, right? So it's 0, yeah. Thank you. So thus U and vector V are orthogonal perpendicular. Very good. Thank you so much for participating. Okay. All right. Any questions so far? I was very rushing, huh? Okay. Okay, let me slow down. Mhm. All right, so we do vector projection. So every time dot product, very useful for finding angle like earlier, and perpendicular. And then number 3 is a vector projection, okay? And I want to make a mention, dot product always gives us number, all right? We can see that, right? So dot product is number, right? And let's go back. Dot product, we multiply addition, then give us a number, right? So let me think. The answer is scalar. Scalar means it's a number, right? Is it spelled right? Scalar. Is it correct? So dot product, thank you. We get number, right? -1. The answer is scalar. Dot product, we get answer scalar, right? Yeah. Okay, let's move on. So vector, you cannot move on. Oh, something wrong. Vector projection. Okay, so from trigonometry, right? So we have right triangle, and this is R, and y equal to x equal to, right? So x represent what? Cosine theta, right? But then we say that R cosine theta, remember? That's why cosine theta equal to x over R, right? Was it? Yeah, very good. Then y equal to R sine theta, right? That's why in unit circle, R equal to 1. So we have simply x equal to cosine theta, y equal to sine theta, right? So x equal to cosine theta, y equal to sine theta. Okay, then in linear algebra, what we do, so instead of R, we make a vector. So that would be V. Okay, then we are using x equal to, look, is R cosine theta, right? So we are using V cosine theta, right? But then we are talking about the length. This is a length, right? But then this is a vector, right? So we want to know about the length because in that case, R is the length, yeah? So how do we indicate the length? Magnitude, right? So magnitude, so vector, magnitude of vector V and cosine theta, right? So Y, same concept, Y equal to, instead of R, we are using magnitude of vector V and sine theta, right? Okay, now, what's the projection? Projection. Okay, so projection, we have vector V, and then we say that vector U. Okay, so I am projecting from terminal of a vector V. So we call this is what? Tip, right? Tip. From the tip, this is a tip. Yeah, project here. Yeah, you guys understand what's the project? If we have a vector V here, project here, right? If we have a vector V here, then project here. Make sense? What's the project means? We make a perpendicular and make that project. Yes? Okay, now, very good. Okay, so we make a project. So project here. Then we call this one is, notation is like that. Projection of vector V onto U. Okay, let me write down. We read this way. Sometimes read the vector or sometimes just omit because we know the vector, right? So vector projection of V onto U, okay? So because we make a vector V project U here. Yeah. So we read this way. Projection of a vector U onto vector V. All right. I'm sorry, vector U. V onto U. All right. Okay. Now, what we are doing? Yeah. Let's see. We start projection, magnitude of projection. So let's start with this way. Magnitude of projection of vector V onto U. Okay, this is same as X, this X, yeah? Okay, then if this is X, then we can express this way, right? So magnitude of vector V cosine theta, right? So magnitude of vector V cosine theta, right? Okay, then cosine theta from earlier dot product formula, right? So cosine theta, which is dot product of u v over magnitude of u and magnitude of v, right? Okay, so we substitute. So cosine theta, let me just copy and paste. Okay, so in that case, we can simplify, right? Okay, then we will have only numerator and the denominator will have magnitude of u, right? So arrange dot product of u and v over magnitude of u. Okay. So we called this is component of v in the direction of u. Oh, too long, right? Okay, let me write down the symbol first. So we're using this way. V onto. So read this way. Component of v in the direction, in the direction of u. Okay, so component of v, vector v in the direction of u means equals the same direction. Means same direction. With the u. Okay, for example, u goes to this direction. So v goes the same direction too. All right. Okay. Now this one has a different name. This one has a name. Scalar projection of v onto u. Okay. let's take a look. We read this one. Projection of vector V onto U, right? If we have a magnitude, then this one is a scalar projection of a vector V onto U, right? Why? Because if we do this one, we get the scalar, yeah? At the end, this is a scalar, yeah? Dot product gives us a scalar. This is also number, right? Okay, so this one, we get formula like that, right? And then this one, we have a different name and different symbol, but it's the same. This is the same as that, and then same as that, right? Okay, this one, we read component of a vector V in the direction of a vector U, all right? Okay, let us do this one. Now, we want to know about projection of a vector V onto U. So, we had earlier magnitude of that, right? Now, we want to know about without magnitude, right? So, what about this one? Projection of a vector V onto U. Okay. So that will be, this is the formula. We have this one, but this one is magnitude of that, right? So we cannot just using by itself because this is not complete one. And we have this one and we make a times unit vector. Okay. So unit vector, let me write down unit vector. Unit vector. So unit vector form is 1 over magnitude of U times of a vector U. So we call this as the same direction of a vector U. We know the vector has magnitude and then direction, right? Then if we say that unit vector, then unit vector has the form. This is the form as a unit vector. And then unit vector goes the same direction of this vector. Okay, in that case, it's a U. All right? Is it okay with you? Too much? Too heavy for the concept? Okay, thank you. All right. Almost done. Yeah, just a couple problems. Okay, then let's do it. So that will be, we have U dot product with V. Thank you. Direct message and message, the chat. And U. And the unit vector, let's using that. How about different color? So copy. Okay, then this is the same, so we can make a square down. And let's just leave U because this is a dot product, right? And then U squared with a length. And then there is just U, yeah? This is a times, this is a dot product, right? This is a times multiplication, this is a dot product, right? Yeah. Okay, so let us do this one. Find the projection of V onto U. Very straightforward. So we are using this formula, right? Copy here. Okay, so do we have a time? Yeah, we have time. So I do one, you do one. Yes. Okay, number one, V equal to 3, 5, 1. U equal to negative 1, 4, 3. Okay, so just copy and paste. So that will be dot product 3, negative 1. It's commutative, so we can do that. Plus 5, 4, plus 1 times 3 over, and we have a squared, right? Okay, so we knew that the magnitude of U is square root of U sub 1 squared plus U sub 2 squared plus U sub 3 squared, right? But then we have a square term, so we make a square term, right? So there will be U sub 1, so negative 1 squared plus 4 squared plus 3 squared. Can you please calculate? Then U is negative 1, 4, 3, yeah? We express this way, okay? Okay, what do you get? Numerator? Let me see. Thank you so much in the chat. Oh, so you multiply everything. Okay, she multiply everything. So looks like 20. So 20 or 26, negative 1, 4, 3. Okay, that will be. Oh, no, that's good. That's good too. Yeah, that's good. Then how do we make a nicer form? This is good. If we want to more simplify, then it's a 10 over 13. So yeah, let's do it. So that will be negative 20 over 26, 80 over 26, and 60 over 26. We can directly from here to here, right? So we can do the negative 10 over 13, 40 over 13, 30 over 13, right? This is the simplest one. We can have that. Don't be sorry. You're good. You did a really good job. All right? Okay. So would you like a try? So let's make v equal to 6, -4, 1. And u equal to 3, 1, 2. How about that try? Hey, thank you. Thank you very much. Okay, so let's using this one. So that will be 3 times 6 plus 1 times -4 plus 2 times 1 over. So we have 3 square plus 1 square plus 2 square and square down. And then 3, 1, 2. Okay. Oh, okay. So what did you get that? Someone who did earlier. Is 16 there? And 15 there? Is 14? Yeah, 14, that's correct. Yes. Thank you. Very good. And 3, 1, 2. Then we can simplify more, right? 8 and 7. And we can have that 24 over 7, 1 over 8 over 7. Yeah. And 16 over 7, right? Okay, we done. Any question? Thank you very much for coming here.